Good evening to everyone. This is Lokesh, and today we'll see what happens when a DNS server is not available or if the DNS server could not resolve the name that we are looking for. Also, we'll quickly see an attack that is associated when this happens. Okay. So before proceeding, I would like to give a quick view on what is a DNS. So DNS is a domain naming system which will help you to resolve a host name into an IP address. Why that's necessary? Because computers only understand numbers, and but we humans are not that much comfortable with remembering numbers. So we have introduced this DNS so that we are very comfortable in remembering names. So when we just type in the name, the DNS will help you to resolve the name into IP address and vice versa. So this helps us to understand or operate, navigate through the network quite easily. So this is a very short gist of what is a DNS, and also I would like to quickly give you on the working flow of a DNS. Okay, so it's not that every time when you search for anything, it will directly go to a DNS server, right? Because if it does, if all the requests directly go to DNS server, the load on DNS server will increase, and also this will become a performance issue because there will be multiple slowness is associated with it, and you will see a considerable performance issue. So to increase it, we have introduced, or we are using multiple stages of DNS query search so that it would be easier for us to resolve. So when we search, for example, let's take a example where we are searching for a file server path. So you are opening a run command and running, and when you search for it, first your system will check in the cache memory. So every OS will have its own cache memory. The memory will be stored in the RAM, and it will consist of the DNS details that is associated with your search queries. So first you will check the DNS cache memory, and if the data is available in the cache memory, then it will just quickly take the IP address and it will search for the IP address. This you can actually see. So you can take this as a quick tip. You can search, you can open your CMD and search for ipconfig/display DNS, and it will display all the DNS names that are available in your cache. You can take it as a nice tip. So let's say the thing that you're searching is not available in the cache. The next place it goes to the host name. So here in the host name, or here in the host file, you can specifically provide the name and the IP address to which you want it to resolve. Therefore, this also makes the querying much faster. And this host name will available under system32 drivers etc hosts. And if it's not available in the host name as well, in that case, it'll go to the DNS server. So once it reaches DNS server does a lot of things. So it will go to top level domain, like root domain, authoritative servers, if required. If not, if it has it, it will provide you the IP address that it already has. So there's like a complete mechanism behind the DNS server, but let's not get into that. So let's say your DNS server is down, or let's say your DNS server could not resolve the thing that you're searching for. What happens then, right? If the DNS service is available, it's well and good. It's very simple. You will get what you're looking for. You will just quickly will be taken to the file server and F1 folder, and you can access all the files that you're looking for. But what if the DNS server is down? What if the DNS server could not resolve this path? Happens. This is when the fallback mechanism kicks in. So Windows have a couple of fallback mechanisms that will be used when the DNS could not be utilized. So these fallback mechanisms are used for on the local networks, and when the DNS is not available, Windows by default, you don't need to enable anything. By default, Windows will adopt it. It's available on all the Windows versions from Windows 2000 or Windows Vista, and it is available in your system as well. What are these two? These two are link local Multicast name resolution, LLMNR, and NetBIOS name service NBT-NS. So these two mechanisms will automatically be followed. The first one would be the link local multicast name resolution, LLMNR. If even that fails, then it goes to the NetBIOS name service. So NetBIOS name service is the oldest one that is available here, and the updated version is the link local multicast. So in link local multicast, it will multicast the request. Okay, multicast the request to the predefined host or predefined configuration that you have made, and it will get a response from those only. And it also supports IPv6 and v4, so that's a plus point there. And NetBIOS is like a oldest one, and it just broadcasts and looking for a response from all the devices that is available there. You know the fun fact? Both of these are a legacy mechanisms. Both of the fallback are legacy mechanisms. They are just being there for two reasons. One, to support legacy systems, and two, it will be used as the last resort to resolve your DNS query. When Windows all other things failed, this will be used. Okay. So now, since these are legacy, these also are associated with multiple attacks. Okay, they can be used or they can be manipulated by malicious actors or hackers to get the credentials or the information that they are looking for. But how, right? Let's take a scenario and we'll just explain on that. So this whole attack that we are going to explain is poisoning attack. It's LLMNR poisoning attack or NBT-NS poisoning attack. So what happens? Let's discuss. This is a usual request. So a client user try to open his system and he tries to access the file server, a very normal thing that it happens day-to-day basis. But if you look closely, the file server, there's a spelling mistake. File SERVR, not VER. Okay. Since this name is different and it is not known by the DNS, the DNS will replay name is not found. Like I could not find the name. It's not available. I cannot resolve it. It will just let know the client. Now the mechanism triggers. Now the fallback mechanism triggered, and the client will broadcast all the request to all the devices that is available in the network. Now it will ask to everyone that does anyone have a file SCRVR? Anyone knows what is the IP address of this? It'll request all the machines that is available in the system in your environment. In normal scenario, everyone will say no, I don't know, and you will get a pop-up stating that this is not the server is not found. Kindly check the path that you have entered and try again or check if the server is down. So those kinds of messages will be displayed. But when a hacker is in place, when he took that request broadcast using tools such as Responder, he will get the request and he will process it and he will send back the message that, yes, I do, I have it. Even though he doesn't have it, he will say to that client machine that I have the credentials and to allow you to use it, I need your credentials. Okay. So the hacker will ask the client to authenticate themselves. So that's when the pop-up arrives, and yeah, the client will happily enter the username and password because it's very normal thing that happens, and he enters, but he will receive an error that the file not found. But the moment he entered his username and password, the hacker got the client's NTLM hash and its username. So Windows won't outright send the passwords. Okay, it will communicate, at least the NTLM, it will communicate using the hashes. And when the password is entered, it will convert it into NTLM hash. So probably NTLM v2 hash, and it will send to the hacker in this time, and the hacker will collect the hash using the responder tool. Now, the hacker with the hash he will take it to the other tools such as Hashcat. So with this Hashcat, he can decrypt or he can guess the password, and voila, he can use that credentials to log into their system. And think, if this credential is a privileged user, think if it's an administrated user, happens, right? Now the hacker has the control of entire network. So just by having the hash, decrypting the password, he got access, right? Now you are in a serious trouble. So this is the overview on the LLMNR or NBT-NS poisoning attack. What can we do? Now we know that this is the attack. What can we do? We do have preventive measures. First and foremost, disable LLMNR and NBT-NS. In this modern times, when in most of the organization, when the DNSs could not resolve, it will usually redirect it to the public DNS server, which is Google. For example, Google 8.8.8.8. Likewise, there are like multiple other things you can use, like HA setup for the DNS server, like primary, secondary, and you can have it in place, or you can also do such things. It is always recommended to disable it so that you won't be a part of this poisoning attack in your environment. But let's say your organization or your managers needs that functionality for some kind of reasons. In that case, you can always insist utilizing the network access control. So that if a request comes from a device which is not recognized, you can always redirect the request to a restricted environment so that the malicious actor or hackers cannot do much of it in the restricted environment. The thing with this also associated with passwords, because once the hash value that we saw in the last slide, right? So once the hash value is received by the hacker, he will use hashcat to decrypt or guess the password. The password is very normal or very easy guessing, like password at 123, P at $$WORD 123. So if the passwords are these, the hashcat2 or any other true formatter can detect or can derive the password in seconds. Make it even difficult for such tools to decrypt. It is highly advisable to have a password, a lengthy password, like 10 to 20 characters with uppercase, lowercase, alphabets, numerical symbols all over in place to make it much solidified, secured, so that even if the hacker gets your hash value, it will be very difficult him to get or guess the password that you're utilizing it. And finally, you can also monitor an unusual logon activities. In case if he logs onto your network somehow, you use some tools such as some SIM tools. You can always take a preventive measures to stop the attack right there. For that, you can always utilize a good SIM solution. So this is the overview on the fallback mechanism that Windows utilize for DNS server, and also the LLMNR poisoning attack. Thank you so much for your time. And if you have any kind of queries, feel free to reach out to me. I'll be here to assist you. Thank you. Have a wonderful evening. Bye bye.